Hello and welcome back. Today we have this UNI-T signal generator, the G962E, and just gonna play with it. I'm gonna do a teardown because I'm trying to see if we can do external reference. Uh, so that would be nice if you like to see the inside. I already announced in the community tab of my channel that I was going to have this power supply. Well, this is not really the power supply. This is the DC converter or buck converter, whatever you want to call it. But this is not the 6006. This is the big brother. This is the 6080, as you can see. So it is 1080 watts. And I ordered it with the case because then it is really as a whole and it looks really nice. And I thought I would have a power supply myself and not thinking too much about the number. So I thought, yeah, I have a little one. I can do a switch mode because in the end it's going to be switched anyway with this head. But this is just, well, it is 12 amps, but it is just 12 volts. So it's like, 150 watts. So I need 10 times that. So so I order one from Linkoja. It's 1200 watts. So this one can do 60 volts by 18 amps. So I ordered a power supply that can do 65 volts because you will have some drop and 18.5 amps. So we should get very close. And it can deliver 1200. So that is enough for the 1080 this one can do. So, but I will receive it probably next week. Also, I was thinking I can do this huge toroid coil, but I think I should not because I can better keep this one for an analog power supply if I also use analog controls. Because as I said, this is just a sort of a very luxurious buck converter, so it will be switched in the end. And then why use this expensive coil? Yeah, I already have it, but maybe I want to build later an analog supply. So if this is switched, no use. I can also do this one switch. So, but that will be next week. Let's have a look at the signal generator. So I knew when I ordered it, it really looked a little bit like an oscilloscope. I will show you the picture. So I thought it would be a little bit like my oscilloscope, but maybe a little bit smaller. So yeah, like this one there. But it was not because I received it and the box was not that big. So here's the box. And I thought, okay, it is not that big. It was nicely packed. I put some bubbles, so that is good. And here it is. It is the UTG900 series. And they come in 30 megahertz and they come in 60 megahertz. And I had the 60 megahertz because it was in the promotion of the anniversary of the AliExpress. So I got a very nice discount on it. Well, I have a measuring tape for inches and centimeters. So for all viewers, that would be nice. So I thought, okay, maybe a little bit like the size of my oscilloscope, and the width there is 30 centimeters or 12 inches. And then the box arrived. And the box, as you can see, is like 20 centimeters or 8 inches. And so that is a bit smaller, but it is still a reasonable size. And of course, I should have looked at the dimension of the picture because some of the pictures had dimensions. But I just already made the picture in my mind, and I just said, okay, let's have it. And then I open it. And look at this! It is like a baby oscilloscope, but it is of course not an oscilloscope. But if you look at this, maybe you cannot even still not make the dimension, but I'm holding it in one hand now, so it's super small. And well, if you look at this, this is like less than 7 inches or 18 centimeters, and the height, well, it's like 9 centimeters and less than 4 inch. But it does look very nice, and it does have a turn knob, and yeah, it looks like nice quality. The box is also nice. Let's have a closer look. A little comparison with the oscilloscope. Look, you can, yeah, well, the other one is more in the back, but you can almost fit 4 or 3 at least if you do like this. So it is a lot smaller. So what else they gave us? Well, if you take out the plastic, then we find a lot of things. We have here USB cable, so it probably runs on 5 volts. This is indeed a USB adapter. It's a bit small, I need to get the microscope, but there are different plugs. US one, I don't see British one, but these usually also fit there, but for this here it's okay. Okay, stuck, plug, good. What else comes? They have BNC crocodiles and BNC. Perfect. Okay, so here we have it. Then we have the connectors, and the BNCs are on the side. And yes, if you put it somewhere in between, that is not necessarily convenient, maybe, but it is probably made just to, I don't know. I would have liked that they make it a little bit bigger, maybe, and just a few connectors in the front, but that would have made it a bit bigger. So yeah, it's a choice. Now to put some cooling, nice. On off, a USB. Yeah, probably to update the firmware. Maybe the software, I didn't check yet. And here's the DC connector, but it looks like a 12 volt DC connector. All the stuff here in my lab with this plug has 12 volts. This one not, it is 5 volt DC. So I really need to keep this cable with this machine, and not by accident. Look in here, my lab power 12 volts. Okay, I connected it with its own power supply, and yeah, it says it needs 2 amps, which I think is seems a lot. Okay, well, it's cool. The display looks nice, I must say. Very bright, very sharp. You have your inputs. One, yeah, the buttons really line up with the BNCs. That is good. And you switch the channels 1 and 2, and I think if you push again, it goes on. Okay, makes sense. Let's see how much power it needs. I think I get my other just to see. Well, I have here this Chinese charger, and cool thing is it reads the power. So it indeed is taking some power. Look at this, 1.15 amps. Okay, but good, we can keep an eye on that. Well, I'm not going to do a full review or a full hands-on, because there are a lot of reviews already. I just want to check the harmonics and the options for the impedance, and then we're going to do a teardown, and we see if there is a possibility to make an external reference. Okay, we'll just play a little bit with the basic functions. So we're just gonna switch it on. Oh, it has a fast startup, And we have here the sine, square, pulse, ramp, arbitrary, or what else we can do? We can do even noise, and we can do even DC. So we can also do a DC source. We can play with that. If we turn, we are now selected on frequency. If we turn, you can go to your frequency, amplitude, offset, and even you can change the phase. And you can see here that we already jumped into the other menu. If we want to go back, you push back on wave. And you can also push instead of turning the wheel. You can also push on the sine wave. And then you come into the same menu. You can use then the dial and the push, or the buttons in the bottom, and what is selected is in the red. So if we go to frequency, we are now on very low frequency, and if I push again on frequency, it changes from kilohertz to milliseconds. So you can just pick yourself what you want. You like frequency or milliseconds. So that's cool. You can also see here that you are here in high Z, so that means it's set to high impedance. So probably we can also change the impedance, so we have a look on that later. Frequency, what should go to 60 now? 60, I just start typing and then I can pick what set I want 60 megahertz, and it is actually doing that. Perfect. Now we have amplitude. I thought it was 20 volts. Peak. The value is out of range. Now on this frequency it doesn't do that. It does 10 volts peak on 60. And how much it can do frequency on 10 megahertz. How much can we do? Can we then do 20 volts? Yes, 20 volts. Okay, we can look in the specs. So on the lower frequency, it really does 20 volts peak, which is a lot. And it's still using more or less the same power, like 1.2 amps. Okay, so we can change the offset. So that means your zero line, you can push up. Oh, that also shows up. It's nice, the phase you can change. It shows very good. That is some nice graphics. Okay, perfect. Frequency. Okay, what if we want to change this thing mode? Our mode is modulation. Our AM, PM, FM, FSK, line and log. We don't want that. That's modulation then. A wave. We are then back in the first menu. Okay, output on off. You can even invert. Here we have the load. So go to channel 1 settings. Output. You can set it on or off, but you can also do that by pushing this button. We leave that as it is. On. Put off. Okay, inversion. We have load. Here you have load. And here we can pick 50 ohms, 75 or high C. It's now in high C. So high impedance, but we can do 50 ohms if we want it. But I saw also here, it says just ohms. 1 ohm, really, you can set even a load of 1 ohm. But then, can you set it to 5 ohms then also? 5 ohms, really? Oh, that is interesting. Okay, just put 50 ohms. And then we probably go back to the wave. And now it's, instead of 20 peak, it goes now to 5. So amplitude, can I put now 10? Yes, I can do 10. Can I go higher? No. Amplitude. Oh. Oh, you can even do your amplitude in RMS, in dBm, or in volts peak peak. That is really cool. 11 peak peak. No. Okay, because of the load, it doesn't do that. So if we go back then to utility channel 1, load in high impedance, wave amplitude, then we can put it now to 20 again. Yeah, so the loads limits the amplitude now. Okay, makes sense. Okay, now I'm gonna do some testing on the oscilloscope. Oh, the signal does look nice. Ooh, not completely, by the way. There's a little bump there. This is only on 10 megahertz. Also, it's a fractional of, it's 9.9999999. So, I'll put the square. Oops. Yeah, that's maybe because of the 50 ohms. I can try to do this in high impedance. Okay, that is funny. They know that their square is not that square. Because if I change the frequency now and I say, okay, we do 1 megahertz, then they think, okay, our square is a square, so we're going to show a square. And they are more or less right. But then when you say, okay, then we put 10 megahertz, yes, they know, okay, our square is not going to continue to be a square, so let's just change the picture. Okay, at least you know what you get. I like that in a sense. But it would be interesting to see what if we just don't use the 50 ohms here. So of course, we're gonna, let me change also here. Utility, channel 1, load, IC. Let me go back to wave. Yeah, it doesn't change the form. Maybe the sign is better in this frequency. Yes. In high impedance, the sign stays nicer. Well, let's see if we go to 60 megahertz then. Frequency, shoot to 60. Just go to the highest. Bang. Yeah, almost. It's a bit low. Yes, it does stay nice. And now I wonder with the, oh, if I do again the load. I put my terminator on the oscilloscope, but now utility channel 1, load 50 ohms, wave, and let's see. Yeah, now it is. Now it stays nice. So I don't know what that was on that lower frequency. Now I like to see what it will do on the spectrum analyzer. I will lower a little bit the amplitude for a peace of mind. Let's say 500 milli top. Okay. The impedance need to be 50. I think I had that. Utility channel 1, load 50. Okay, that was already good. Wave, sine, frequency. It does work, really. It just does what you think it should do. Okay, I try on the. Now I want to look for harmonics. I put a reasonable, only 500 millivolt peak. To be careful with the spectrum analyzer. I have here the 10. I started to go up to 20 and we see nothing, so I need to, the stop frequency need to be higher. Let's put 100 and it is very clean, and there are no harmonics in that sense. I found that very nice also with the field tech. I was actually surprised that the suppression of the harmonics is really good with these Chinese devices. And of course, if we use a square, it will be worse but it's just because it's not because of the device, it's because it's a square. And yeah, you can watch other videos about that. I can show you if I now put the square, you will see immediately that harmonics will come. And I should be able to see easily how I can do the harmonics. Yes, here I can. I will zoom in on that one moment. So even though it does have harmonics, but it's because it's a square, there is still a difference of 60 dB with the first harmonic, and it's the third harmonic is 13.8, so almost 14 dB. Then the fourth again is more than 60 dB, and the fifth is 27 dB. So there is, even though there are harmonics, they are really a lot less. On 60 and 30 megahertz, no harmonics. The suppression is really good of this machine. Okay, let's do the teardown because I wonder what this is oscillator runs on. Hopefully it's 10. And then we can maybe make an external reference, as I did also with the field tech, because it's now a little bit off. And also because it can do FM and AM modulation, this could be a nice radio tester. Also, it goes up to 60. Yeah, the problem with these warranties is I don't think there is a store in the Netherlands here that would accept it when I bought it from Ali. So that means I need to send it back to Ali and shipping. That will cost me so much. So in a sense, the warranty is, yeah, doesn't mean that much. I would just break the seal. And not saying that you should, but yeah, you know, if shipping costs me like 40 euros, yeah, then it doesn't make sense to ask for it. It is still double the price, but then they need to send it back. So you need to think if you want to open it or not. But on the other side, mostly the warranty doesn't mean that much. So I did open all 4 screws, and let's see. Yeah, oh, there it goes. Well, I immediately unplugged. That was a bit rough. I already unplugged the cable. If there was, yeah, there was. That was a bad job. You need to push the bottom and the top to carefully open it. Okay, luckily the cable just popped out. Just gonna go a bit further in to see what is there. I think my hand is in his way. Four screws there. Let's keep these screws here. That is from. Okay. I'm a bit rough today. I'm sorry about it. Oh. I'm missing one. Yeah, it is down. Can we get it out? I think because they were able to get it in. So I have the most space here. Here I need space, but it is now locked to the power switch. But maybe if I put it like this, it will just be, yeah, that is the trick. Okay. Well, some relays here. Probably the big chip, create the power, some DC converter stuff. Well, this we need to put back later. To put the cable back in. Let's look for the oscillator, if it's on this side or the other side. I will get it now under the microscope. Let's see if we can find what we are looking for. Okay. Well, it's already focused. Here it's not, but this seems like a DC stuff. Yeah, they took out the. Where is my big CPU here? Yeah, here also. They sanded it off so you cannot see. Oh, look at the traces. They made some delay lines, I think. Okay, cool. And okay, yeah, close to the, I think we have it. This is the USB connector, and behind the USB connector, this could be it. This is the B10QT, so this could be the oscillator. We can probe this later, because if I look at the rest, nah, this is probably it. Okay, I reconnected it again. Let's see if we can power it on like this, and then let's probe these. Yes, it seems to power up still. Okay, okay. Well, it seems this is all ground. Can just pick it here. This was ground, so there is nothing here. Here is a C. So let's see what we have here. Now you can't see the oscilloscope, but I can. And this is a signal, but this is 50 megahertz. 50 megahertz exactly. Well, I think that's the oscillator, because it goes directly into the chip. It says here the B10QT. So for me, I thought, okay, that was 10 megahertz. But if I probe it on the frequency counter on my oscilloscope, they all say 50 megahertz. So then I thought, okay, maybe it is a problem with harmonics. So I put it on the spectrum analyzer, and the spectrum analyzer says the same. It is 50 megahertz. So I'm trying to find out now what is, if I can find the oscillator. But in the end, if it's 50, then it's 50. And it's just not that convenient, because the GPSDO does 10 megahertz. But it was the same with this other. This is an ADF 4351. This one I also created external reference, and there it was 25 megahertz. And to get those 25 megahertz, I use the PLL. I have here a 6-channel PLL, and you can just program that to 50 megahertz. And this one is also on 10 megahertz reference. So then in the end, I should have a proper 50 coming out of this one. But then it becomes already a bit complicated. So let's see what we can find about this oscillator block. Well, the output was here, this pin, and there is only one resistor. And so I think we can, reasonably easy tap our signal here, and we can just take out the resistor and use maybe another resistor with the switch. So we can just put the switch here in between with the resistor. So we can leave the block alone, and we can inject it right there. So take the resistor out, put 2 wires, put the resistor back on the switch, and also inject the signal. Here is in, I think it's 33 ohms, it's in series. Well, first I need to do some testing, but I think that if it works, if we can inject here the 50 megahertz, that I will put a switch right here on little wires. So we just connect it like this, and later we can put it in the casing like here. Then I have this SMA that I connect to the switch, and then we can put it outside, because there is a lot of space, but also we need to be careful where is the space. I zoom out a little bit. Yeah. So if this goes in here, this fits all nicely. Then with the wires, I could just push the switch out there. It will fit exactly right here. And then the signal is very close to its oscillator. So that would be good. Then this one is connected to the switch as well. It goes through this hole. Yeah, this. Then, so that is not a problem. Then this goes out here on the top. We just drill a hole there, and there is enough space here to get it out right here. So, but first we try if we can even inject the signal. So first I will remove the heatsink just to get better access to the resistor right there, because it is all very small. Let me just get to the screen there. So here we have the resistor that I'm going to take out, and there we need to I'm doing some measurements. I have put now my 6-channel PLL to 50 megahertz. I'm measuring the output, and I can put a screenshot. It is about 1.35, 36 millivolts on the output, peak. So let's see how much we had, because I forgot to note that down on the directly from the original oscillator. Well, that one is 1.44, 45. So it's almost the same. The wave also looks kind of similar. So I think we can proceed. That will work with the PLL probably. Okay, this is going to be a bit exciting because I got my huge weller, and I'm not sure if you can see the resistor there. I can zoom in a little bit. Right there. And I just need to try to get this resistor out. Oh, there's a little bit of dirt there. To get this resistor out here and put 2 wires, and maybe just put the resistor straight up to keep it on the input. So we have a little bit of resistance there. But this heatsink is in its way, so I will remove that first. And I think I will put the time lapse because it will take a while. Well, I'm going to try now to get rid of the resistance. There is still a little dirt on it. Still, okay. Well, first make it a little bit warm. Okay, well, in the end, what I just did is put my point just on the both of the together, and then it just went off. And I will now put the 2 wires there. I will try to clean a little bit. Okay, the wires are connected. This is from the oscillator, so we keep it as it is. And this is that needs to go into the IC. So we want to have there the we want there the 33 ohms. Oh, I have it here. First, I want to put it on the I want to have a ground. I hope I can get it here. Yes, I can. Good. A little bit here. Good. Well, now for the test, I will just do it like this. But later, it needs to go the other way around. Yeah, okay. We hear the signal. Let me just make this a little bit shorter. Connect it to the. Okay. Okay, so now we have the 33 ohm E series. This needs to go to the PLL. So yesterday we found out a lot that, and I'm still confused, and I can call it a fail, but I don't want to do that yet. When we measured on the oscillator, it said 50 megahertz, but when you look at the markings on the oscillator, it should have done 10. And I check in the oscilloscope, check on the frequency counter, and I even check in the spectrum analyzer, and they all agree it was 50 megahertz. But when I injected 50 megahertz signal, it didn't want to respond to it. So maybe it's still 10. I really don't know. And the signal also didn't look very nicely as a square. It was more like a triangle. Yeah, so I think I'm just going to continue. I will just make the switch as I planned. I will put the SMA output also, or input also, as I planned. And then later, because I'm just testing it, and at some point some of the wires will break. Also this little cable, I opened, closed, and locked and unlocked it now so many times, I'm afraid it's gonna break. But in the end it doesn't matter, because the seal is already broken, so the warranty is lost. So I'm just gonna continue, put the SMA connector, close everything up. I will put a little cap of 100N or something, just to make some sort of DC blocker. And then I just can insert any signal I like, just to see when it will respond. And I think that will be better for the circuit board. And I probably put 50 ohms on the input, 47 ohms, just a little bit, because here comes 5 volts. This one does a little bit less, and the oscillator did 1.5 I measured, which is very low also. That was also weird. So just to be sure, 50 ohms, 100 ohms. Let me just see. And if it doesn't work, switch it back to internal reference. We use that. Okay, drilling the holes is done. I managed to put exactly in the middle for the switch. So then after the circuit board is put in, we just put the switch here, and it goes exactly in between the two connectors. That is good. Also, instead of putting it on the top, but in the end I thought it was really ugly, I just drill a hole here in the corner, and it was an exact fit. And the board on the top doesn't touch it. And if I put the connector here to the side, it even locks against the body right there. And then we can just put a net here. And then it's not even that bad because it's just on the side. So we have nothing on the top, in the back, or in the bottom. So here we have the reference and the reference switch, internal, external. Now let's connect. Okay, I will just leave it running. So here we have the two wires. That was the original connector, the original connections to the resistor that we have here. That will need to go to the switch. So we're gonna connect it to the switch. Everything goes through the resistor first. So the resistor we can maybe connect to the middle pin, because the middle pin is going to be the chip. Let's do that. Okay. Then we get the resistor. Let's make that a lot smaller. So the middle pin is the board. Okay. Also short. Maybe it is smart to even put a little shrink. I think I will do exactly that. Several sizes here. All the resistors need to fit. Maybe it does. Here, something left? Yeah. Maybe smaller. This one. Yeah, that goes. Then this is the side of the chip. Oh, shaky, shaky. That is stuck. Perfect. Okay, where is my... Yeah. That is done. Well, then one of the two. So to the front is internal, then to the back becomes external. Or I do it like this. No, I can't do it sideways, it needs to fit here. Okay. Which one feels best? To the bottom, because I need to stick it later. Or like this. I think like this. Or can we just... Okay. This one. I'm so shaky, my god. Okay, that's a good fit. Then this can go exactly Yeah, it's not touching anything. Yeah, okay. I don't like it. I also put here shrink. More tiny. Perfect. Okay, that's done. Then we can now put it back in its place. Like this. Carefully with the switch. Then we need to push it back. Chuck, there it is. So this is now in the correct position. And now we need to see if we can, maybe I can give you a better look. And now I need to try to get the switch back in with the connector to the top. That one, that still needs to. And it was sticking out too much, and I think I have two nuts, so I put first the first nut. The DC plug is there, so I don't mind if it's a little bit sticking out. Come on, please go. Yes, exactly, it goes. Look. Yes, there it is. See, perfect fit. Also the wires. This is good enough. We put the other nut just in top in. No problems there. Perfect. So to the front means intern, to the back means external ref. And let's tighten that a bit. Yeah, it is a bit tight, but it's good enough. The plug will fit, USB will fit. Okay. Now we connect this one. And what I wanted to do here is put a little capacitor to couple it. I think you can see better like this. Yes. So I put this here. I want to put a little cap, but I also want to put a resistor. So first I will connect the cap. to the switch. I'm a bit shaky today. Now I can put it upside down. There is more space there. Yes, that seems good. And then I can put the resistor, and then I can connect these like this. Okay, let's get the resistor. Okay, I have 47. Close enough to 50, a little bit less, so I can put a little bit more signal. I'll try to put it exactly here. It will need a lot of heat. It has, okay. Let me just connect also these two parts, because it seemed the back was moving, and I do want to have a proper ground. Okay. Those are connected. Yeah, my point is a little bit too small to do that. Let me cut a little bit this one. A little bend, yes. Then I can cut here. This needs to go away from the other pin. This I don't like. Go back. So here I have from the switch, it goes to the 50 ohms, so the signal will come in here. It goes first to the 50 ohms, then through the cap, through the switch to the chip. Well, that's the plan. So let's connect now the cable. First check if there is enough space. Yes, it goes this way up. And nothing is touching it. There's enough space in between. So no problems there. But I will put also some isolation maybe in the top there, so it doesn't touch. Bend this a little bit down. Sorry, bend this a little bit down. And now we can put the cable. cable should just go over the resistor. Okay, I'll change the point. Okay, now I have a little bit of a bigger point. The heat transfer will be a lot better than this tiny point, but the tiny point I needed, here look, so much more easy. But I needed a tiny point for the SMD. Yeah, perfect. Okay, this is there. So the signal goes in with the 50 ohms to the ground with the, I think it was 100 and to the switch. And this can go in. But of course first it needs to go through the protection, and I want here to put some isolation just to be sure. So I will put some tape. So it's around here. I will just put it here. So even when it touches, at least it doesn't short. Just a precaution. Yeah, that's good enough. Okay. Then I already tried that this goes through this hole. Then no, this silly thing. Yeah. Okay, well, we try to put the screws. This can go on top. Perfect. Okay, I managed to put the screws back in. I have this magnetic screwdriver, and then carefully you can put it in, otherwise it will take you hours fiddling around. Well, it does look like everything is well in place. So now we can try to put this one in its spot. As I said, it is so tight it automatically locks in, which is great because then there are no problems there screwing it tight. So let's just put that in. I think I will give it a little bit of force so the cable will go down. Yes. Some people don't like what I do now, because you need to maybe use a proper tool, but if you are careful you can do it. And look at that, it is not that bad. Yeah, and now I made a mistake. I need to unscrew it again because I forgot to put the flat cable. Okay, well, I just unscrew everything again, connected the little flat cable, and now we can do a test before I completely switch it up, at least that its normal functions are still working. So let's connect the little flat cable. Push, push, okay. Well, it seems that it all still fits. If we look here in the cable in the back, and then you push. Yeah, it's already closed. Well, let's have a look if its standard functions at least are still working. So I need power. It needs to be switched to the internal reference. This forward this is so. Yes, no problems here. It does switch on. Now we can look if it does give an output. Can you see the frequency counter? Yeah. Switch it on. It's external ref, so heating it doesn't make too much. Channel 1. Let's do 10 megahertz. Oh, yeah, this is test mode. Frequency. Channel 1. Yes. Okay, of course it both need to stabilize, but at least it works. So the normal function still works, and probably if I switch it over, it will just stop. Yes. Back to internal reference, and then it needs to restart. Well, we saw the same with the field tech, that it would stop after it got confused. Yeah, and it goes again. So that was a fail. The trick I used to make external reference on the field tech absolutely did not work on this one, but I didn't have a schematic diagram, but I don't know if it worked, if it would have made a difference, because I just found the oscillator. I tried to inject there the signal, and it just didn't work. I tried different waves with my field tech, squares, triangles, well, you name it. It has a few. It seemed to run on 50 megahertz inside. It's also, even if it did work, it is not that convenient to make external reference for 50, because then somehow you need to get your 10 up to 50. Well, I have a little PLL here, so it would have been possible. Now I'm using the field tech that is connected to external reference to use then this one on external reference, and in the end it doesn't make sense. So, but there was a weird thing, because on the oscillator block, if it was, I think it was the oscillator block, it said 10. So I would have thought that maybe it's 10, but on the spectrum analyzer it was not. Yeah, so we have the nice modification, and maybe later I will try again, or maybe if someone has a schematic, maybe there is a loopback system somewhere, and now of course by making the external reference, the loopback is also gone, so maybe that is a problem. Well, I can show you the modification. The switch is here. To the front is internal ref, so then it just is, you can use it like this. It switches to external, and that means you can input the signal there. So it's not that ugly, but it just doesn't work. That's it. I wish it worked. Well, I spent now 2 days, and so if someone does have a schematic diagram, just email me or put a link if you can, because then maybe I can continue the project. Yeah, but for now, people have asked me, can you try this? Well, I tried. The field tech was more easy. So if you still need to make the decision and you want to make external reference, not base it completely on my findings, but take them into account, that this one was very easy to do and this one is not done yet. So that's it. Thank you for watching, and I hope to see you next time.